And here we are for video 2 for section 2.6, and we're continuing with the infinite limits, or limits dealing with infinity. Now, every once in a while, or as I mentioned before, sometimes we get 1 over 0, or 7 over 0, or really any number over 0. And up until now, that has always been, it's undefined, we can't do it. Well, now actually we can come up with a particular value, and that is it could be either positive infinity or negative infinity, depending on how the signs work themselves out. You know, whether it turns out to be positive, it would be positive infinity, or negative. Now realize this only works if we're going with limits, because limits ask where is it approaching. So we can bend the rules just a little bit to try and do some calculations here. So let's suppose we have the limit as x approaches negative 5 from the left of 1 over x plus 5. Now if we look at this and we just try to do direct substitution negative 5, we get 1 over 0. Got a problem. So what we need to do here is we need to think this one through. We're going to do a direct substitution, but we're going to do it intuitively, meaning this. I'm going to say the 1 doesn't change, but now I'm going to put in negative 5, but I'm actually going to be coming in from the left-hand side. Negative 5 from the left-hand side plus 5. Now let's look at how this changes the problem slightly. We're still negative 5 plus 5 is still 0, but what we want to look at is, are we coming in from 0 from the left side or the right side? So negative 5 from the negative side might be negative 5.00001 or something like that. And so that negative 5.00001 plus 5 would be negative 0.000001, or in other words, it's 0 coming in from the left-hand side. Now we do have to think that way through on these types of problems, because now look what happens. We have 1 over 0, which we know is going to be some sort of infinity. But the question becomes, is it positive or is it negative? Well, since we're coming in from the negative side, this will have a negative sign. This is a positive sign. Positive divided by a negative is negative. And so the limit here would be negative infinity. Now we have to go through all of that thinking whenever we get a value other than 0 over 0. Because remember, if we have 0 over 0, that's an indeterminate form, and we have to do something else to get past that. But realize that we can still graph this, graph 1 over x plus 5, and look at negative 5 coming from the left-hand side. It will appear to go to negative infinity. We know there's an asymptote there. It will appear to be going towards negative infinity. Number 8, the limit. As x approaches 3 from the left of 5 over x squared minus 9. Okay, now, whenever we throw in powers, we have to deal with that just a little bit differently than we might otherwise consider. So let's look at this. Suppose I'm coming in from 3 from the left, so that's 2.99999 as an example. And if I take that 2.99999 and square it, that is going to be really, really close to 9, but it's going to be slightly short of 9. You know, 2.99999 squared is 8.9999 whatever. And then I still have to subtract the 9 from it, and we get 5. Now once again, we get the 9 minus 9, that's still a 0, but what is important to us is this coming from the left or the right? Well, if 9 negative, 9 from the negative side, so this means 8.999 minus 9, that means this is going to be a negative. 0 is going to be from the negative side. So we're going to be negative 0.00001 or something like that. And so then the question becomes, we have a positive over a very, very small negative becomes a negative infinity. Once again, you need to just think it through, you know, what sort of value. And if you have to, just plug in some bogus values. Plug in 2.99999 and square it and subtract 9. You'll see it's going to be a negative 0.000 something. So it's really close to 0 on the negative side. Number 9. The limit as x approaches 0 from the right of 1 plus cosecant of x. Okay, of course I had to throw cosecant in here. But let's just realize what's going on. First thing, it would be real nice if I just plugged in 0 into cosecant. Cosecant of 0 is undefined. We've got a slight problem. But realize I can do the thinking. I can say, let's put in cosecant of 0, almost 0, but we're coming in from the right. Now, all of us are really good trig people, and we remember that as we come in from the right, heading towards 0, cosecant goes to basically infinity. It goes up indefinitely. And so this becomes 1 plus infinity. Now we get a little bit of a difference here, or a different situation. 1 plus infinity. Well, let's see. If we take infinity and add 1 to it, because that's what we're asking, where are we at? We're still at positive infinity. And so, anytime you take infinity and you add a number, then that's going to be equal to infinity. Some of the problems you can't worry about. I mean, if you have infinity plus a negative infinity, that does not necessarily equal 0. You have to do something else. If you have infinity plus infinity, that's still infinity. That is nice. Likewise, negative infinity minus infinity is still negative infinity. And so if you don't try and counteract infinities, then you're doing okay. Okay, example number 10. The limit as x approaches 1 from the right of x squared minus 6x plus 5 all over x cubed minus x. Now we can do a couple of things. First of all, we could be looking at the bullies. You know, here we have a bully of x cubed, and we could technically start dividing everything through by that. But and that certainly would work. However, I might suggest this looks like it could factor relatively easily, and this too. And let's see what we end up with when we factor it. The limit as x approaches 1 from the right. Okay, this factors to x minus 5, x minus 1. And the denominator here, we can pull out an x, which leaves x squared minus 1, but x squared minus 1 can factor to x plus 1, x minus 1. And look at what happens. The x minus 1's cancel, which really gets rid of the whole problem, because x approaching 1, the only problem was this factor right here, because this equals 0. So now, if we just do a substitution, and we really shouldn't even have to worry about the coming from the right. It's just plain and simple. The limit as x approaches 1 exists. So it doesn't matter if it's limit as x approaches 1 from the right or the left, or just approaches 1, because we can find any of those. So it's just substituting, direct substitution. 1 minus 5 up here, 1 times 1 plus 1. That becomes negative 4 over 1 times 2, which is negative 4 over 2, or negative 2. And this one is where the graph really comes in to play. I mean, if you would graph this, you would see very plain and simply that as x approaches 1, y is getting closer and closer to the value of negative 2. And the final example for this video is example number 11. The limit as x approaches 5 from the right of 1 over x to the 4/5 minus 1 over the quantity x minus 5 raised to the 2/5. Honestly, what I would try to do here is do direct substitution, and with the understanding we might have to deal with zeros in the denominator, but all we really have to do there is to make sure we're dealing with, is it on the positive side or the negative side? And so we get this situation first of all. Direct substitution would say, okay, I'm going to take 1 over 5 raised, and this is 5 from the right side, raised to the 4/5 power. Now here's where we're going to potentially get some really strange things going on, but let's continue. And then here we get 1 over, okay, now if I plug in the 5 minus 5, that's going to give me my 0, and that's where the problem is. However, 0, is it going to, we look at this is a little bit bigger than 5 because we're coming in from the right. So just slightly bigger than 5 minus 5 is slightly bigger than 0. So it's just slightly bigger than 0 going to the 2/5 power. But then the question becomes, let's go on. This becomes 1 over 5 to the 4/5. This doesn't really cause a problem. We don't need to worry about that plus. You know, 5 can be in the denominator. That's not a problem. But what happens here? Well, 0 positive squared would still be positive, and taking the 5th root of it would still be positive, but we get infinity. You know, 1 over 0 is infinity, and we're subtracting that infinity. So now the question becomes, we have this number here. It's relatively small. I don't even know what it is, but it's relatively small. I do know that much. And we're subtracting infinity from it. We have a number minus infinity will be negative infinity. Just like a number plus infinity is infinity, a number minus infinity is negative infinity. Infinity plus a number is infinity. Infinity minus a number is still infinity. You know, infinity is the biggest bully of them all.